My objective for this problem is to identify the center, major vertices, minor vertices, and foci of this ellipse. Since I already know it's an ellipse and I already have the formula, really it's just visualizing what this ellipse looks like and being able to use basic geometry to find out these specific coordinates, okay? So since the bigger number is underneath x, I should visualize, again, you don't have to draw it, but just visualize a short, fat ellipse, okay? Now let's start filling in the information. The center is already given to us, so it's going to be 1, comma, -3. It's really important that you get that center correct, because if that's incorrect, then obviously that's going to influence all the other answers. Okay, what the heck is the major vertices, the minor vertices, and the foci? So once again, this is just going back to A, B, and C. A is the distance from the center to the major vertices. In this case, A is 10, so I like to write that number right here so I don't screw up. B is the distance from the center to the minor vertices, these guys. Okay, so B in this case, it's staring right at me, which is 8. And then the foci, these guys here, is letter C away from the center. Okay, so what the heck is that? Well, I don't see it in my formula, but I do know that the anti-Pythagorean theorem will give me that. So a squared minus b squared equals c squared. So 100 minus 64 equals c squared. So c is going to equal the square root of 36, which is 6. Now, the reason why I like to write those numbers there is those are the numbers I'm going to be calculating with, okay? So the major vertices, let's take a look at this. So I know from geometry that the major vertices are left and right from each other. That means I'm going to change the x-coordinates when I move left and right. So if I change the x-coordinate, my y-coordinate should be exactly the same as the centers, okay? So that means all I have to do is take this original x-coordinate, add 10, that means moving 10 to the right, I'll find this guy. And then also subtract 10 from the x-coordinate, that's the same thing as moving left in geometry, so that's going to give me -9, okay? I'm going to do the same exact logic with the minor vertices and then the foci, okay? So for the minor vertices, they're above and below, which means I change y, but I keep x. These x values should be exactly the same as the center, since really I'm just moving up and down. So how much do I move up or down? 8, okay? So -3 plus 8, that means I moved up to find this guy here. It's going to give me 5. And then -3 minus 8, moving down to find this coordinate, is going to give me -11. And then last, but certainly not least, is the foci. Now again, the foci is very similar to the major vertices because they all line up. So by the same logic, it's going to keep the same y-coordinate. All I'm going to do is I'm going to change the x. How much am I going to change? 6. 6 to the right, so 1 plus 6 is 7. That'll give me this guy. And 6 to the left, so 1 minus 6, that's how we move to the left, -5. And I have all the coordinates I need.